In this lecture, I am going to discuss about a very important topic that is called electric field. Let us see what is meant by electric field. So this is the definition for electric field. Electric field refers to the region surrounding a charge where its influence is felt, and this concept was introduced by Michael Faraday. Now let us see what is meant by this statement. For that, consider a positive Q charge. It is a point charge which is placed at some region in space. Okay, now you know that all the charges will either attract or repel any other charge which is near to it. So this charge will be able to exert force on any other charge which is near to it. Okay, now your charge is positive Q. We want to define the electric field for this charge. So the electric field related with this charge is defined as the region in space, which is nothing but some region of space near to this charge, where this charge can exert force on any other charge. So if you place a charge here, if this charge is exerting a force on this charge, either attractive or repulsive, depends upon the charge you are keeping here. If this charge is able to exert a force on that charge, then you can say that the electric field of this charge is extending up to this region. Okay, now imagine that you are placing a charge here, and if this charge is able to exert a force on the charge which is here, then you can conclude that the electric field of this charge is extending up to this region. So now I think it is clear. Electric field of a charge refers to the region surrounding a charge where its influence is felt. Now for the given charge, if its electric field is in this region, if this is the region of space for this given charge where its electric field extends, it means that if you place any charge in this region, if you place a minus Q charge here, then this charge will exert an attractive force on the minus Q charge. Okay, so from the diagram, since this is the electric field region for the charge plus Q, if you place any other charge in that region, then your plus Q charge will exert a force on that charge. Okay, which means that its electric field will be extending in this region. Now outside of this region, if you consider here, its electric field is not there, because electric field is only in this region, up to this region. So if you place any other charge on that region, then if you place a plus Q or minus Q there, then your charge which is already there, it is plus Q, will not exert any force on this charge, because the electric field of this plus Q is not extending up to this place. It is only in this region. Its electric field can only be in this region, so that this charge will not exert any force on this charge which is outside the electric field region. So by checking the region where its electric field is extending, you can say that whether the charge will exert a force on any other charge or not. Okay, so I will give some more examples. If you place a minus Q here, then since the minus Q is outside the electric field region, your plus Q will not exert any force on this minus Q, because it is not in the electric field region of plus Q. Okay, like that, if you place some other charge plus 2Q here, now you can see that the plus 2Q charge which you placed is now inside the electric field region, so that your plus Q will exert a force on plus 2Q, and that force will be repulsive, because plus Q and plus 2Q both are like charges. Okay, so if you keep a charge inside the electric field region, then the charge which is extending that electric field will give a force on the charge you placed. Okay, and if you keep any charge outside the electric field region of a charge, then the charge under consideration will not exert any force on the charge you placed. Okay, so again you can come back to the definition. Electric field refers to the region surrounding a charge where its influence is felt. So the electric field of this positive Q is nothing but the region around this positive Q where the influence of this positive Q can be felt. That means whether this charge can attract or repel any other charge, how much distance it can attract or repel any other charge. That region is defined as the electric field of this charge. Okay, I hope it is clear. This concept was introduced by Michael Faraday. Now, generally electric field is studied in terms of a quantity which is called intensity of electric field. It is generally denoted by the letter E. Now let us check what is meant by this intensity of electric field. So before going to discuss what is meant by intensity of electric field, I want to discuss another term that is called test charge. So test charge means a unit positive charge is called a standard test charge. The word itself says what is meant by this. Whenever you want to check what is the electric field in a region, then you will need the assistance of test charge. Okay, so test charge is defined as a unit positive charge which is considered as a test charge. Okay, now in the coming discussions you will understand what is the use of this test charge. So I will discuss what is meant by intensity of electric field. Okay, so this is the definition for intensity of electric field. Generally electric field is discussed in terms of intensity of electric field, and intensity of electric field is defined as intensity of electric field at any point is defined as the electric force per unit positive charge, that means test charge, placed at that point. Okay, so intensity of electric field at any point, you can simply find it by finding how much electric force is acting on a unit positive test charge placed at that point. Okay, let us see an example. Imagine that you are having a charge plus Q at this region, and this charge will exert your electric field. Its electric field will be extending in some region. You want to find the intensity of electric field at this point. Let us say this is P. At P you want to find what is the intensity of electric field. That means E. Intensity of electric field is E. This is a vector, so there will be vector sign. Intensity of electric field is a vector. Okay, so there will be vector sign. You want to find it. So how to find it? This method is easy. According to the definition of intensity of electric field, intensity of electric field at any point, here the point is P, is defined as the electric force per unit positive charge placed at that point. So you are going to find the intensity of electric field at this point. It is given by the force acting on a unit positive charge. So you want to find the force acting on a unit positive charge. Unit means plus 1. Unit positive charge. So plus and unit means 1. Okay. So unit positive charge if you keep here at P. Okay. How much force is acting on this plus 1 charge due to this plus Q charge? That is the intensity of electric field at that point. So how to find the force acting on unit positive charge placed at that point? For that, instead of a unit positive charge, imagine that you are keeping plus Q charge there. Instead of this plus 1, if you keep plus Q, imagine that you are keeping a plus Q here. Now find the force acting on plus Q due to this plus Q. Let it be F. Okay, so when you place a plus Q at P, imagine that it is actually acted upon by a force of F. So for plus Q charge, a force of F is acting. So for plus Q it is F. So for plus 1, how much force will act? It will be F divided by Q, isn't it? For plus Q it is F. So for plus 1 it is F by Q. Now according to the definition of intensity of electric field, intensity of electric field is defined as the electric force acting per unit positive charge. Here you got, for unit positive charge, the amount of force acting is F by Q. So the force acting on unit positive charge is called the intensity of electric field. Now from here you got the force acting on unit positive charge is F by Q, so that you can write a generalized result as this is nothing but E. E is the force acting on plus 1 charge and it is given by F by Q. So what is the final equation for intensity of electric field? It is equal to total force acting divided by total charge, from which you can write F is equal to Q into E. If you cross multiply, you will get this relation. Electric force is equal to charge into electric field intensity. This intensity of electric field is simply called as electric field. Normally it is intensity of electric field, but we will use the word electric field. Instead of intensity of electric field, most of the textbook will simply use electric field. It means intensity of electric field. So intensity of electric field means the force per unit positive charge. That unit positive charge is called a test charge placed at that point. So how to find it? Imagine that you are placing a positive Q charge there. You are placing a positive Q charge near to a positive Q charge. So you want to find the intensity of electric field due to this positive Q charge on this point P. So you will place a positive Q charge there and find the force on that positive Q. Then that force divided by the charge you placed there, positive Q, you will get the force acting on unit positive charge plus 1 charge, and that amount of force is called the intensity of electric field. Okay, now what is the dimensional formula for intensity of electric field and what is the unit for intensity of electric field? Let us see. From the last discussion, we got intensity of electric field E, which is a vector, is equal to total force acting on Q charge divided by the charge Q. This is the equation for intensity of electric field. E is equal to F by Q. Now from this you can find the unit. So how to find the unit? What is the unit of intensity of electric field? Okay, just follow the same method which you already used in 11th. Unit of E is equal to, what is the unit of force? Unit of force is Newton divided by, what is the unit of charge? It is Coulomb. So unit of intensity of electric field is Newton per Coulomb. So this is the unit of E. Okay, now what is the dimensional formula? Use the same method. You have E is equal to F by Q. F is a vector, so F vector sign. Now what is the dimensional formula for F? You already know, mlt raised to minus 2. This is the dimensional formula for F. And now Q, charge. For Q there is an equation. Q is actually equal to, Q is equal to, or let us use small letter q. Q is equal to total current multiplied by time. This is the equation for Q. So Q is equal to I into T, where I is the symbol for current and T is the time taken. Okay, so the dimensional formula for current is I itself. Just like mass we are using capital M, time we are using capital T, length we are using L. Like that for current, dimension symbol is I, and for time you already know it is capital T. So the dimension formula for Q is IT. Okay, now substitute here IT. Now from this you can see what is the total dimensional formula for E. M L T raised to here minus 2, and here there is a T. If you take it to numerator, it will become minus 3, and there is an I in the denominator, which will become I raised to minus 1. Okay, so this is the dimensional formula for electric field intensity or intensity of electric field. Both the words are same. Generally we will simply use electric field. Okay. Now let us derive the equation for intensity of electric field at a point due to a point charge. For that, let us consider a charge placed at a point. For simplicity, let us consider that a charge Q you are placing here. Due to this plus Q, this is a plus Q charge, this charge will have its own electric field because it can exert attractive or repulsive force on any other charge when placed near to it. So that region where this plus Q charge can exert force is the electric field region for this charge. Okay, now we are going to find the intensity of electric field due to this charge at some point. So let us consider a point which is r distance away from this Q, and it is the point P. At P we want to find the amount of electric field. In order to find the intensity of electric field or the amount of electric field at P, the procedure is that you need to place a unit positive test charge there and find the force on that unit positive test charge. So instead of keeping a unit positive test charge, let us first keep a plus Q charge there. Okay, so you are going to keep a plus Q charge at P. Now you can find the amount of force on that plus Q. How can you find? Here there are two charges, one capital Q and one plus Q. So two charges are there. Force acting on this small letter plus Q at a distance r due to this capital Q is given by Coulomb's law. You know already equation from Coulomb's law, 1 by 4 pi epsilon 0. Force acting on plus Q due to capital plus Q, 1 by 4 pi epsilon 0 Q1 Q2 by r square. Here we are assuming that it is placed in air, that is why epsilon 0. Next one is Q1 Q2 by r square. Here instead of Q1 it is capital Q, Q2 is small letter q. We don't need to consider the sign, that's why I am considering both are positive, by distance square. Here distance is r square. This is the force acting on plus Q. Okay, so sorry, force acting on plus small letter q due to capital plus Q. Okay, so F capital plus Q means force acting on small letter plus Q due to capital plus Q. Please remember the notation. Okay, now we want to find force acting on plus 1 charge, not on plus Q charge. We want to find it on plus 1 charge. From the above step you got for plus Q charge, for plus Q force is 1 by 4 pi epsilon 0 1 by 4 pi epsilon 0 q by r square. This is the case for plus Q. So for plus 1, how much it will be? That will be F by Q, isn't it? So that will be 1 by 4 pi epsilon 0 q into q divided by r square, so that you are dividing with a small letter q. So the small letter q on numerator will get cancelled with the small letter q on denominator. So you will get q by r square. Okay. So here you can see this total force by q, that is defined as electric field intensity. So you got the equation for electric field intensity at a point P due to a charge capital Q. It is given by E is equal to vector E 1 by 4 pi epsilon 0 Q divided by R square. This is the equation for electric field at a point due to a point charge capital Q. Okay, so from the equation you can see that the test charge is not coming in the equation. In the given equation you can see there is no term small letter q. Only the charge which you placed positive q and the distance to a point is there in the equation. Test charge won't come in the equation, but for finding this you need test charge, but in the final equation test charge won't be there. Okay, I hope it is clear. This is a very important equation. Now based on this and the concept of superposition, we need to solve a huge number of problems. Okay, very important concept, so please practice it. So here please remember, we are writing the total electric field vector, so that this is only magnitude, you need direction also, so direction will be r cap. So final equation for electric field will be 1 by 4 pi epsilon 0 q by r square into r cap. This is the case when you have a positive q charge here and at a distance r you are having a point P. The electric field intensity or electric field at E, if you want to find, you can use this equation 1 by 4 pi epsilon 0 q by r square into r cap, where q is the charge you are keeping and r is the distance. The test charge you are keeping is not coming into the equation, please remember. It is only for finding force and it will not come in the final equation. Okay, so I hope it is clear what is meant by electric field intensity and what is meant by a test charge.